the videos describing the user interface for the Basic X software on a RAM Sprint system. In the first part, we went through the user interface and explained all of the functionality that exists, or the majority of the functionality that exists. In this portion of the demonstration, we're going to go back and actually show you how to program on the machine. What I'm going to do first is go back and just show you a little bit using just normal functionality in the software. And I'm going to turn off all our lights as we start here. And just turn on the backlight. Now we're turning on the lights of the system. I'm using the knobs. We can also turn on the lights using the light bars and knobs that are on the right-hand side of the image window. If I grab one of the pointers, I can turn the lights up and down dramatically as we're looking at them, or physically turn them right off by just clicking on the light itself. Right now we just have the backlight on, that's the bottom light, and again I can go back and change the intensity of that also. When we physically measure, I'm going to go back and start at a corner. And let's use a manual target first. We measure a distance. I've got the circle target up. I'm using the right mouse button as a joystick. My lights are a little bit bright. I'm saying about 70%. I'm going to turn it down just a little bit. The image should always be dirty looking, never white. And again, if we just follow that rule, then you'll always have something that measures without any issue. If I come back on the bottom of the display now and set my XYZ zeros, I'm going to go over to the other hole if we want to measure the distance between two holes. And I'm going to use the right mouse button again to position the circle inside. And as soon as I hit the axis alignment button on the DRO window again, you'll notice the y-axis goes to 0. And it tells me the distance between the two holes is 2 inches, 9/10 thousandths. If I go to metric, it's 50 millimeters, 824 thousandths. And we can switch back and forth between inch and metric as we're going through the software anytime that we want to. I'm going to select right now the most widely used target, which is the feature finder. And to measure the circle, I'm just going to double click on the edge. And it measured the circle. I'm going to say OK. I'm going to go over and measure the other circle again using the feature finder. And again, we don't have to center it in the field of view. The field of view is calibrated, or the image window itself is calibrated also. So whether I measure in the center or off center, we measure just as accurately. In the model window now you see two circles. And what I'm going to do is we want to make those two circles my datum. I just say construct datum. I'll select the circle and tell it to 0 my X and Y there. And I'll say OK. And then I'm going to select axis alignment. I'm going to come over and pick the other circle. And I'm going to tell it to align the X-axis. Now when we're doing the alignments, I can align it to a basic angle if I want to. I can do an X basic or Y axis, or I can align the second hole to an angle from the first. It really depends on how your print's dimensioned. I can also do the axis alignment in the Y axis. We can do it at the actual location, the nominal location, or at the feature direction. So again, a lot of flexibility in letting it do it the way you want to. If we want to go over and measure a couple of slots to get some widths, I can come over with the same target that I measured the circles with. I can just drag and drop. I'm using the enter key on the joysticks to close the step after I measure it, and just drag and drop along the edge. You'll notice every time I do it, I get another line in the model window. If I want to measure the width, I just say construct width, and I pick the two lines, and it told me the width was 1.376 millimeters. Now if I want to print it, I just click the print button. I'll say again, and we'll measure one more width as we went through. And we'll print out the diameter on there also. On the two circles in the first two steps, I didn't print out the diameters or anything on those. If I wanted to print them out, I'm going to scroll back up to the beginning. And I'm in my circle step right now. All I have to do is click P, and it automatically prints that diameter for me in the window. If I come back to the next window, and I'm going to do P again, and it automatically puts that in the window for me also. Again, we can, the blue banner, if I double click on it, it expands it so I can see more of the print window. And right now we see the two diameters and the two widths that I measured previously. If I want to measure an angle, I'm going to go to the outside edge of the part, and And to measure an angle, I just got to measure two lines and tell it to construct the intersection between the two. So I measured a line, hit the enter button, measure another line, hit the enter button, say construct intersection. And now I go back and I just pick the two features. Right. You'll notice that we have a block. Right now it's at 314 degrees was the angle. Now, the angle that I'm looking for is near 45 degrees. We show you all four angles so that you can always print or display the angle that you're looking for on your print. If I select angle 2 told me it's 45 degrees, 8 minutes, 5 seconds. Right? If we go back now and run this, the machine will mimic everything that I've done. You're actually creating the part program as you go. You don't have to compile anything, save anything. You're ready to measure as soon as you're done. I don't have to go back and reestablish machine zeros or do anything else with it to keep the program going. I'm going to come over on another feature now that's very hard to image. And yesterday we talked about the manual input point target. And I'm going to use that now just to kind of give you an idea of how it works. All right, what we're looking at now is a piece of black plastic with rubber impregnated on it. And the edges are there. I want to measure this diameter, and it's very difficult for me to see. So I'm going to turn on the smart ring light. I'm going to turn off everything but the segments I want. And I do that by grabbing any one of the legs with the right mouse button and going in a counterclockwise direction. Now I believe all I want is two segments on to see this. Turn power on. And you'll notice that makes a big difference in the image that we were looking at over the standard ring light. I'm going to turn that off completely now. And you'll notice as we're looking up in the left corner that this image is very, very good here. If I rotate it, that image will physically move with the reflection of the light going across it. So I'm going to tell it that I want to measure a circle again. But I'm going to use the manual input target this time. And again, on low contrast edges, certainly I think with this light we can still measure it, but we have the ability also to measure it with this target. So I picked a point here, picked a point here, and I pick another point here. All right? And I'm going to say OK, and we'll say we're done. I believe I can take the feature finder and measure that also, just by picking 3 points along the edge. Again, very low contrast. I'm not sure what the variability that you'd see between parts, the feature finder would be reliable here. Where the manual point entry target certainly would give you a lot of flexibility. We're going to go back and run what we have so far, and you'll see that it'll measure the holes. After it measures the holes, it'll measure the slots. We're going to go over and measure the intersection of the angle, and now we're going to come over and measure the manual point entry. Now with the manual point entry target, it shows me where I took that first point, and I have the opportunity now to pick the edge. The machine's not doing it for me, I'm picking it myself. As soon as I pick this last feature, and we only pick 3 points on this circle, it's going to measure it automatically with the feature finder. So in this case we can image it well enough to measure with the feature finder, but if it was bad enough that I couldn't, we still have the ability to measure it. And I'm going to go back and rotate the light around now so that you can see the edge and what it does for the image, where it'll really bring out the edge dramatically, and all I'm using is 2 segments of the lights. We can turn on a complete section of the lights. I can turn on any one of the rings of the lights as you're going through. So we have a tremendous amount of flexibility in the light to illuminate anything you want. Since we don't touch the parts with the video, where I'm measuring the image, it's critical that you get a good image. And that light certainly lets us get the image without any problems. The next target we're going to look at is the laser on the system. And I selected the laser target. It tells me it's not deployed. I'm going to tell it to deploy the laser now. So the laser's down in measurement position, and we're ready as soon as it gets down to its 0 point for us to start measuring. Now, when we use the laser, we set up all of our initial measurements or what we're going to do with it with the video. And the reason being is that certainly with the laser, we can't tell where it's really going to hit until you start measuring. And this is the part I'm going to measure. And before we do this, let's look at the focus target once more. We haven't been doing anything with focus targets. Let's take a couple of points on the part. And I can come down any place I want to on the part. I'm going to select the focus target. I'm going to tell it to go up in magnification. Certainly, if we want an accurate measurement in Z, I've got to be at a reasonably high magnification to do it.